All right. So because I don't remember where we left off, we're going to start off right here. So there might be some overlap in the videos. All right. So when we're solving this, the first thing we want to do is we're going to make this into the exponent. So we're going to use this to do the exponent rule. So in order to do that, use the coefficient one-to-one property. We can't do that yet. So we're going to use the power rule to kind of do that. Next thing, now that we have it in this form, now that they're both ln's, we can combine them using the difference rule, or they call it the quotient rule. So quotients makes it able to use this difference, this subtracting there. From here, what we're going to do is we're going to try to get rid of this ln, and the only way to do that is with the inverse. Nick's going to get on me because I forgot to look up how to do this, but it's the inverse property to use the e instead of, I call it basing. And then from here, we can basically split this off or solve it through algebra. We can multiply ex by both sides. So this says 1-to-1. We can't use 1-to-1 exactly yet. Take the natural log of both sides. That's the opposite of what we want to do. We already did that. So we just solve for x using algebra. And unfortunately, that's all they do. They just like, oh, just use algebra to solve the rest. All right. And then the next one we're going to do here, that's right. We're going to do compound interest. So solving for compound interest is this idea of interest making interest over time. So when we're solving for this, the number in the front, this P is known as our principal. It's what we always get. R is our rate of change. And T is the time it takes to do that. So when we're doing this, if we're starting a bank account, we're starting with $1,000. This is going to be our P. The E is our exponential thing. You're going to learn more about that when we're doing our research paper. R is our interest rate, always in decimal form. And T is the amount of time it takes to compound. So if this is this much interest in a year, then we're going to do it in a year. Also, it's important to know that E is when it's compounding continuously. That means every second of every day it keeps compounding. Usually we don't use E except in cases of like bacteria and things like that. Some bank accounts, I think they keep track of it differently. They keep track of it similar to E. E's usually pretty spot on. It might be off by like a little bit. So this is usually how we want to calculate continuous growth is with E. So if we're doing this, so John borrows $2,000 from his dad. So this is known as our principal. This is what we're starting off with, how much debt he has. Get my pen. So this is how much debt he has. Oops. I always forget I have to do that. So P equals 2,500. His dad feels he needs to charge him interest. 6 months later, John repays his dad this much. So interest was charged. We just don't know how much interest. What is the annual? So if we're talking about annual, we're talking 12 months. So the way we would calculate this is this ends up being our A, our accrued. A stands for the accrued, so everything that we got after it. So this is going to be 2,588 equals 2,500, which is our P. And we have our E. We don't know what our R is. That's what we're solving for. And our T is, it hasn't been a full year, 6 months out of 12. So our T ends up being 6 over 12, or we can do it as 1/2. Or even then, we can just change this to 0.5. From here, what we're going to do is we have to use our algebraic properties to divide. So what we're going to do here is, let me pull out, oh, I'll do it on the Google calculator. So I get this 1.053. So I'm going to copy that, put that over here. 1.0, did I say 53 or 35? 352. 352. And that's going to equal our E, R to the point times 0.5. Now we have to ln both sides. So we're logging both sides by our power. In this case, our base is E. Logging both sides by our base. So we have to take the ln of whatever 1.0352 is, and that's going to equal our 0.5r. From here, what we're going to do, clear this out, clear ln 1.0352. I always say it backwards. And we get this number right here. So I'm going to just round that off to 0.035. I'm going to round that off to 0.035 is equal to 0.5r. We're going to have to divide by 0.5. So since this is already here, might as well divide this by 0.5. And I get 0.07. If I do this here, I don't know how accurate this wants it to be. So about 7% interest. 0.07 interest. I did that. What is the rate? Does it want as just 7? How specific does it want it to be? 6.9%? Huh. Oh, they got really specific with it. They wanted 3 decimal places. This is one of the things that bugs me about Admentum. Keep in mind, guys, if you guys are doing a teacher graded activity, I'm not going to be this specific. I hate how specific this is. And the main reason is it didn't say 2 decimal places of the percent. It didn't even ask if it was percent. So technically, because of their restraints, this should also be a correct answer. Let's see how picky it is. Nope. It literally wants you to do it as a percent. So that's just Admentum being picky, guys. It's not the math that's hard. It's just Admentum really wanting you to solve it the way they want you to solve it, even though technically, if you're doing math, that should be a decimal, not a percent. All right, from here, again, we're just going to use population growth. Population growth does usually grow continuously. This number E comes up a lot. And when you guys read your paper for your activity, you'll see why it comes up a lot. So when we're doing this, the spread of a virus. So this is how this virus is growing. I think if we go back to what I did before with logistics, this is a logistic growth where at first it grows really fast and then kind of tops off and slows down. I don't remember though, I would have to look it back up. But the main thing is we just want to solve for this. So where n is the number of people, so n is the number of people after t days. How many days will it take for this to affect 1,500 people? So what we're doing here is we're just solving for n. So we plugged in n and we want to solve for our t. So they gave us n, we solved for t. So now we're going to do 1,500 equals this. So one thing that I want you guys to remember is whenever you have something equal to a fraction, I just want you to do cross multiplication. It'll just make it feel a lot easier for you guys. So give me a second while I copy this down, 0.5t. So pretend that there's a 1 here, and then what we're going to do is we're just going to cross multiply. This is the same thing as multiplying both sides by the denominator, but it's a good visual way for you guys to pick this. So when we're doing this, we're going to see it as 1,500 parentheses 1 plus 100e negative 0.5t equals 25,000. And what will happen here is once we multiply this out, we end up getting this thing that kind of looks like P1 plus R to the T. This is a formula we use when we're talking about exponential growth. So this is where this is coming from. This is a logistic growth, but you can see that it's an exponential growth when we look at it this way. So when we're doing this, we're going to distribute this out. We have this 1,500 plus, we're going to add 2 zeros. So 1, 2, 3, 4 zeros all together. And we have that E.5t, 25,000. Now we can do basic algebra until we get to this E. So we're going to subtract 1,500,000 E.5t equals, once we subtract that, I want to say it's 3,500, 2,000, or 23,500. 2, 3 minus 23,500. From here, we have to divide. So I'm going to divide this by 150,000. We're going to get a decimal from that. Divide by 150, 123. I'm just going to do it as 0.16. Hopefully this doesn't end up being too picky. So I end up getting E.5t equals 0.16. Then I'm going to ln this. Luckily, there's an answer key on the Google calculator. So what you can do is you can always do ln, whatever your answer was, and they'll just plug this number into here. So I'm getting a negative number here. So I get 0.5t equals, I don't see why it's negative. That's weird. And I'm going to divide that by 0.5. Oh, because it's going to be a fraction. This t ends up being a negative exponent, so it ends up being a fraction of the time. What was this? Negative 185. Negative 1.85 divided by 0.5. Divide this by 0.5. Get negative 3.7. So I'm not sure what exactly happened here. All the math seems right. Let's see where I might have made an error. Why is it negative? So apparently this was supposed to be a negative. Let me see why it would be negative. Oh, there's a little negative right there. If we zoom in, we can see that it was supposed to be a negative. So that's why it ended up being negative. This, I forgot the negative right here and the negative right here. So that's what's happening is I totally forgot to put a negative there. So my answer was right at about 4 days. It's going to take it about 4 days. So again, guys, you can take a picture of your work if you do it on paper. So if you're writing your notes on paper, great. Take a picture of it, upload it right here, and that'll help you get through it. So moving on here, now we're talking about radioactive activity. So this is the same idea. This is our accrued, this is our initial, and our rate of change. So this is because it's half-life, what's happening here is it's negative because it's decreasing. It's a half-life. Which time does it take for the materials to decrease in half using the formula here? So did they give us an initial amount? In addition to the radioactive lifespan of this. That's talking about a virus. Using this equation, derive the equation that can calculate the half-life of a certain material. Okay, so all we're literally going to do here is we're going to plug this in. And since it's a half-life, we're going to have to we're going to have to make this like as if it got cut in half. So the way to do that is think about this as half of whatever we started with. So think of it as our AT is now a half and our AO was 1. So when we plug this in, it's 1/2 equals 1 times E negative RT. And they want us to solve for T. They want to figure out how much time it takes. So in order to do this, we are going to have to ln both sides. So we're going to do ln of 0.5 equals negative RT. And we're going to get T equals ln of 0.5 over negative R. Or in other words, what's ln of 0.5? Ln 0.5. So we get this 7 divided by 0.70. 0.70 or 0.69. Where are we? There we are. 0.70 over R. So T equals 0.70 over R. I'm not sure how specific Edmenta wants the answer, but to me, this is fine because it doesn't tell us how many decimal places we want this at. So let's see how specific Edmenta wants the answer. So Edmentum did want it pretty specific. It wanted 3 decimal places. So this is how we would calculate the half-life. How long will it take for something to be cut in half? Once we know what the R is, we can figure that out. Self-evaluation, right? What you guys thought was hard, what was easy. This one always takes me a minute because we kind of have to like pretend what's happening here. They said it kind of as saying that AT equals half of AO, which makes sense actually. We're just replacing that in. I like saying this 1/2 thing because those AOs, this AO cancels out with this AO once we start dividing. So when we divide both sides, they cancel out. Moving on. Let's give this a second to load. Any questions so far? Are you good? While this is loading. 19. Okay, cool. So now initial amount. So our A sub O is 25. Our R is, this is a percent, so we want to change it to 0.0128. You always want to change it to a decimal. How will it take for it to grow? So how long will it take for the population to grow to that? So our A after amount of time, our A sub t is 3.5. So when we do this, we're going to do 375 equals 25 E 0.0128 times t. So we're just going to have to solve for t. So first things first, we have to divide. So 375 divided by 25. 25 divided by 25. We get 15. So 15 equals E 0.0128 T ln both sides. So in other words, ln of what the answer was we got before, ln of 15 equals 2.7. So we get 2.7 equals 0.0128 t. We're going to divide this by that. So divide by 0.0128. And we're going to end up getting 211.6. 211.6 should be 212, but it looks like they're satisfied with 211. Cool. All right, and now we're going to do earthquakes. So we're doing an earthquake of Japan. So remember that earthquakes are calculated by the Richter scale, log of whatever the initial earthquake we can feel is. This one, they're comparing the earthquake to another earthquake. So this is the first earthquake, and they want to see, like, well, if it's 6.5, like, how much is the next earthquake gonna be that we're actually talking about? So let's see what we're doing over here. And so in this case, they're showing us how to solve for it. I'll let you guys view this on your own so you can read about it. But I'm going to go straight into the problems. We can also use it for pH. This is what it's saying here. I remember we had a hard time with pH. I'm not a science teacher, so it's really hard for me to kind of explain how they want to do this. They're using, I forgot what this is called. I want to say it's hydroxide. Anyways, hydrochloric acid. Okay. I can't really get into the chemistry part of it, but I can tell you the math parts once you give us the numbers. So they're just putting in the concentration and solving for it. These brackets right here are just plugging in the concentration of that chemical, whatever it is. So you can see that here. If the pH is this, we're plugging it in for pH, and we can find the concentration by basing it by 10, using the inverse property by 10. And I'm sorry, Nick, I forgot to look that up. I had it in my Batman book, but I didn't look it up. So now we're going to calculate this. So they give us the I, it looks like. So they just want us to solve for D, the level of sound in decibels, defined by this, where I is the intensity of sound measured, blah, 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 determine the level of decibels. So this one, we're literally just plugging it in. An easy way to think about this is -5 to the 10 to the -16. We can use what we know about exponents to know that we're subtracting here. So this is the same thing as saying 10 to the -5 minus the -16. We're doing subtraction because it's on the bottom. So this ends up being 10 to the 11 because this negative and negative turned into a big plus sign. And so this ends up being 10 to the log of 10 to 11. Now remember, this is log base 10. So what we're asking here for this log is we're essentially saying what power of 10 gives us 10 to the power of 11? Well, that's just 11. So in other words, we're just saying 10 times 11. Let me do this in black because I'm talking about the 10 on the outside. So this all ends up turning into just 110. So this should just end up being 110. And if we submit it, we can see that right here. Wait, 100? How did that happen? Oh, that's a 6. Oh my gosh. They really need to make these bigger. Again, guys, if you guys get this wrong, I don't fault you on it. They're just really, really bad at showing this. So those were supposed to be 6s, apparently, which makes this 10 to the 10. Then if we do log of 10 to the 10, we get 10. So that's how we end up getting 100. So that was just my bad eyesight on the screen. To predict the number of some areas, we're going to use this formula where k is the constant. Is the number of species. If the number of species of that in the area is this, and we got that. So this is our A. We need to solve for our K. So in other words, our N is the number of species. So we have 5,800 equals K, which is what we're solving for, log, and then our A ends up being this area, which is 750. So we're going to end up, first we can figure out what this log of 1050 is, or 750. Log of 750, we get 2.88. I'm going to round it to 2.88. So we get 2,800 or 5,800 K, 2.88. So essentially what we're doing is just K equals 5,800 divided by 200, or 2.88, not 200. There's a dot there. I didn't want to make it 100 times bigger. So if we submit it, we can see all the work that they're doing right here. They got really specific with it. And then from there, we can figure out how many species are left. So we have to figure out the K. Oops, went too far. We have to figure out the K, and then we have to figure out how much once it gets cut in half. So that's where they plug in this. We're taking that area, cutting it in half, and plugging it in to solve for N. And that part, we can basically just do everything I did here, except now we have a K, and we'll solve for N. And then just solve the evaluation. My evaluation would actually be just nitpicking off the fact that they need to make their writing better. Other than that, it was pretty simple. I would actually lower my grade a little bit too, because if I were to do it, I totally was not paying attention to this part where it's like cut the rainforest in half. This surprised me when I saw that part. I was like, ooh, I forgot to do the rainforest in half. All right, and of course this is taking forever to load again. Slide 25. All right, so now it wants us to solve for the concentration of this. So for pH, it was always pH equals, I believe it's negative log of the concentration of, is this hydroxide? It's going to bug me now. H3O. Trio. No, I want to know what it's called. Chemical formula for no hydrogen cation hydronium. I forgot it had that fancy of a name. Hydronium. And apparently, there's a video talking about the difference between hydrogen codon and hydronium. All right, so we're going to do hydronium. So when I calculate this out, I'm going to put the pH is 8.45, negative log of this. So since this is a negative log, we're going to make this negative, just to move that negative over. And then we're going to use the inverse property, which is what I call basing. Our base here is that invisible 10. So whenever you see a log, it is a 10. Hey, Thomas. You can just watch what you missed on the YouTube video. We're almost done. Sorry, I forgot to send out the reminders. So there's an invisible 10 here. So with that invisible 10, we're going to go here. And that's going to give us our hydronium concentration. We just learned that that's called hydronium. And they have it. Why do they have an exponent here? Oh, I see. Once we plug this in, it's gonna. No, that shouldn't be like that. I don't know where they got that fraction. Formula for pH. Yeah, I did that right. So 10 to the negative. That should be a decimal though. I got that. Gotta do log to the other side. Huh. What did I do wrong? This is a percentage. Make it negative. You have to base it to the power of 10 because it's log, not ln. Yeah, I know. That's what I did. I doubt that's going to be anything different. It should just affect the decimal places. So give me a second. 10. Oh, but it's a fraction. That's right. The decimal messes it up. Okay. I thought I didn't have to do this, but I do because of the decimal. The decimal makes it a weird number. 45. So we get 3.5 to the negative 9. 3.5 to the. Yep. So what essentially happened, guys, was I was thinking, oh, you just moved the decimal place over 8 spots, but I forgot about this decimal. That decimal changes it quite a bit.
Hello.
Hey, I can
Hi,
hear
Mr.
you.
Victor. I thought this class was at 10:45.
Oh, don't worry about it. Like I said, I was telling Lily this is more just a recording, so you can always just watch it later.
So, do we have anything at 10:45?
We don't.
Okay. So is this like the last class to make up for Wednesday?
Yeah, this is the class that we're using to make up for Wednesday, but that's it. Like the video will be, I'll have the video up by lunchtime. Don't worry about it.
Okay, cool. Thank
No
you.
problem.
I was just confused because like I saw this in my Google Meet and I was like, I thought this was at 10:45.
Oh no, sorry. I was sick, so I probably
It's
just
fine.
rushed what I said.
That's fine.
And then that's our summary. So you at least got to see the ending, Thomas.
Yeah.
All right, but I'll post this video up right now. That way you guys can check it out. All right.
Okay.
All right.
Cool.
See you guys on. We don't have class on Monday. I'm giving you guys the long weekend to kind of catch up. So we're gonna start
Okay, for sure.
unit 3 on Wednesday.
Okay.
All right, guys. All right, have a good one. Sorry for the
You too, bud.
misinformation.
It's